So rewriting probabilities. So that cumulative formula we've been looking at just before, it looked like this, didn't it? The probability that x is less than or equal to x. But sometimes we might want to work out things like this. Now our formula doesn't do this, so we need to convert those probabilities to use the less than or equal to sign. We will always try and use the less than or equal to sign. So let's see some examples. Coin is tossed 10 times. Find the probability it lands on heads less than 5 times. What we're asking for there is we're asking for the probability that x is less than 5. Now that hasn't got a less than or equal to sign, it's got a less than sign, so we need to convert it. So this is just a kind of an image to give you an idea of how to visualize how we change it. So if x is less than 5, it can be 0, 1, 2, 3, or 4. They're the possibilities. So that's the green bit here, is showing us what values are allowed. Now that means, if we think about it, that we could write it like this instead. We could write probability x is less than or equal to 4, and that would give us the exact same values. So that's what we'd convert it to. And now we could just use the formula we used on the previous page, whereas with the less than sign, it's not obvious how to use it. Okay, so that's one example of a conversion. How about this one? 20 customers are surveyed. Find the probability that more than 12 of them buy milk. So we're asking for the probability that x is larger than 12. How do we rewrite that? Well, have a look at this image. We want the probability that there's 13 people, or 14, or 15, or 16, or 17, or 18, or 19, or 20. Okay, we want everything larger than 12. Now this whole bar has a total probability of 1. Okay, all the possibles. If I do probability of x equals 0 plus the probability of x equals 1, so on and so on, all the way up to x equals 20, and add all those together, it must equal 1 because that's all the possible outcomes and all the probabilities must sum to 1. Okay? So to find this green bit, what I'm going to say is, well, I can find this bit here, which goes from 0 to 12. Okay, now that probability is written like that. Probability x is less than or equal to 12. Yeah, that's that bit in there. Now I know the whole thing is 1, so if I do 1 minus the probability x is less than or equal to 12, I'm left with this green bit that I actually want. Okay, so all I've done there is rewritten that probability to use the less than or equal to sign instead of a larger than sign. Now I can use my cumulative formula. Okay, so hopefully that made sense. I've said the whole bar is equal to 1. And I can subtract off the probability x is less than or equal to 12, and that leaves me with this probability here. Let's have a look at this one. 30 people are surveyed. Find the probability at least 15 people have a nut allergy. Okay, so that's the probability x is larger than or equal to, because I said at least 15 people, which includes exactly 15 people. So I want this green area. The whole bar is 1. Yeah, we said because it's the sum of all the probabilities has to make 1. So all I'll do is I'll say, well, I can figure out this grey bit here. That is the probability x is less than or equal to 14, because I want to include 15. That's part of the green area. So I want to get rid of the probability x is less than or equal to 14. I can do 1 minus that probability, which leaves me with the green area. Okay. And there you go. I've rewritten it with the less than or equal to sign. Now I can use my cumulative formula. I've got a couple more examples, which are a bit more complicated, so bear with me again. Coin is tossed 10 times. Find the probability it lands on heads between 3 and 7 times, inclusive of both. Okay, so the area I want is this 3 to 7, inclusive of the 3 and the 7. Well, this is how we write the probability. Is the probability 3 is less than or equal to x is less than or equal to 7. So remember your inequalities from AS Pure Maths, it's just like that again. Once you've written this bit, we have to figure out how to actually write that just with less than or equal to signs in 2 separate probabilities. Well, we could say we'll take this whole bit here from 7 all the way down to 0. Okay, so that's the probability x is less than or equal to 7. And we'll say, right, we've got most of the bit we want. All we want to do is get rid of this grey bit here. We just want to get rid of those bits. That is the probability x is less than or equal to 2. So I just want to get rid of the 0, the 1, and the 2. So if I do this one, subtract this bottom one, or this one, subtract this one, I'll be left with the probability I'm after. Okay? Because I want 3, 4, 5, 6, or 7. This one gives me everything. Okay, it gives 0, 1, 2, 3, 4, 5, and 6, and 7. All I'll do is I'll get rid of 0, 1, and 2, and that leaves me just with the ones I want. Okay, so hopefully you can see how that works. This time we've said, I'm actually just given a probability. Now, this, it's 8 is less than x is less than or equal to 12. So because there's just a less than sign here, it doesn't include 8. It only includes 9, 10, 11, and 12. They're the ones I want. So the way I can write that is I can say, well, I'll take everyone up to and including 12. That's the probability x is less than or equal to 12. But then all I'll do is I'll get rid of everyone up to 8. So the probability x is less than or equal to 8. I'll subtract that off, and that way I'm only left with 9, 10, 11, and 12. Okay, so hopefully you can see how that's working. We're just converting these inequalities to use the less than or equal to sign. That way we can apply our cumulative formula. And also, if we use the tables, as you'll see in the next section, we need to use this sign as well because the tables use this less than or equal to sign.